Let's consider this question. Step number 1. Apply direct substitution. Substituting and solving carefully, you got 0/0. Next, step number 2. Apply LHopital rule. But before we do this, let's recap on differentiation. Let's differentiate cos square x, which can be rewritten as cos x all squared. The dy dx is minus 2 sin x cos x using chain rule, which is usually solved like this. When you multiply these two and you replace u, you are going to get this back. Likewise, if you include a pi to this question, your answer will not change. Just the pi is just attached to it. Subsequently, this and this are the same. To differentiate this using chain rule, we are going to differentiate this first, and the answer is everything here, which we have already analyzed. Next, we are going to differentiate only the sign, and you will have cos. Next, you are going to recopy back everything here inside the bracket, and this becomes our dy dx. Also, if we include a pi in this question, the solution will be the same, except the inclusion of the pi in the final result. Likewise, if you remove this sign and replace it with cosine, also including the pi, the final result will include a pi here, and this cosine will become a sine with a negative, and with the pi inclusive. This will become the answer using chain rule, and this minus can take away this minus. With all these concepts in mind, we can now apply LHopital rule to this function. Differentiate the numerator, which we have solved earlier, and this will be the answer. And now we got this. Next, differentiate x squared, and you're going to get 2x. Next, take the limit as x tends to 0. That is, in place of all this x, I'm going to have 0. This sign will generate 0, and at the denominator you equally have 0. Hence, we are going to have 0/0. Next, in step number 3, we are going to apply LHopital rule again by differentiating each of these variables separately. And in the differentiation of the numerator, we are going to apply product rule. That is, everything here is going to be u, and everything here is going to be v. In step 3, we are going to differentiate the numerator using product rule. Hence, I will keep this constant first. Next, I will differentiate this, which we had differentiated earlier. Still working on the numerator using product rule, we have a plus. Next, we are going to keep this constant. Next, we are going to differentiate this, and here we are going to apply product rule. Here we kept this constant and differentiated cos s, and we got minus sin x. We now included a plus, then kept cos s constant and differentiated this. Next, at the denominator, we differentiate 2x and our answer is 2. Next, we take the limit as x tends to 0. That is, wherever I see x, I'm going to put 0. Then this will be 0, this will be 0, this will be 0, and this will be 0 as well. And you are now left with only these two, and 2 at the denominator as well. Next, step number 4. Take the limit of the remaining function. This will give you 1, and this will equally give you 1. Pi in front of a trigonometric function is equal to 180. Substituting and solving carefully, your answer is, from the options, you can check out for other videos. In PRECALCULUS. To locate all these videos, follow the link on the screen. I will see you in the next video.